Over the past several decades, China has undertaken significant river engineering projects, including the construction of the Three Gorges Dam. While this project contributed to national development, it also resulted in the relocation of more than 1 million people and the submergence of historical sites. Currently, attention is turning to the Tibetan Plateau, where the proposed Yaxia Hydropower project represents the next phase of China's water management strategy. Positioned as part of China's broader green energy initiatives, the project connects national infrastructure development with international climate objectives. The Yarlung Tsangpo originates on the Tibetan Plateau. It holds cultural significance for local communities and plays an important role in the region's ecosystems. One notable geographic feature is the Great Bend, where the river enters a deep canyon. This area presents significant hydropower opportunities. However, the region is also characterized by seismic activity, including earthquakes and landslides. Downstream of the Great Bend, the river becomes the Brahmaputra, which supports communities in India and Bangladesh and is a subject of international discussion. The Yaxia Hydropower project is designed as a large-scale dam, representing an unprecedented undertaking in hydropower construction. The proposed structure at the Great Bend is expected to generate up to 60 gigawatts of electricity, which is approximately 3 times the capacity of the Three Gorges Dam. This project has the potential to provide a substantial portion of China's projected energy needs. The construction site presents significant engineering challenges due to its remote location, high altitude, and seismic activity. Yaxia is intended to be the final installation in a series of dams along the river, with the goal of optimizing energy production. The project represents a major advancement in hydropower development and will assess the capabilities of current engineering practices. Chinese authorities present Yaxia's electricity output as a step toward greater energy security and a transition to cleaner energy sources. The dam is projected to generate 60 gigawatts of renewable power, which may contribute to reducing coal consumption and supporting China's climate goals. The development is also anticipated to support economic growth in Tibet by providing employment opportunities and improving infrastructure. However, these potential benefits are accompanied by notable trade-offs. Constructing Yaxia involves addressing some of the most complex engineering challenges found in large-scale infrastructure projects. The region's seismic activity requires continuous monitoring and careful design to ensure dam safety in the event of earthquakes. The remote, high-altitude setting presents logistical difficulties, necessitating the construction of new roads and tunnels through mountainous terrain. The project demands advanced technology and sustained human effort to maintain progress under challenging conditions. Environmental considerations include the risks of landslides, reservoir-induced seismicity, and variable geological conditions, all of which require ongoing assessment. Each stage, from initial design to integration with the power grid, involves pushing technical boundaries and adapting to site-specific challenges. The Yaxia project represents a significant undertaking in engineering, environmental management, and regional development. The Great Bend is recognized as a region of high biodiversity, supporting rare species and unique ecosystems. Flooding the canyon for the dam would result in the loss of habitats, alter fish migration patterns, and affect populations of endangered wildlife. Local Tibetan and Monpa communities may experience relocation and changes to ancestral lands, as well as adjustments to cultural practices. Previous dam projects in China, such as those on the Mekong, have led to concerns about downstream ecological impacts and limited transparency. Planning for the Yaxia project has involved restricted public participation and minimal independent review. Environmental groups suggest that projects of this scale require comprehensive evaluation and open discussion. The potential impacts include significant changes to natural environments and cultural heritage. For India and Bangladesh, the Brahmaputra is an essential resource for agriculture and daily life. China's management of the river's headwaters has led to concerns about potential changes in water availability, flood patterns, and regional stability. The dam may reduce the flow of nutrient-rich silt downstream, which could affect farmland productivity and food supply. The project is also viewed in the context of ongoing border discussions and broader regional relations. There are additional concerns about the cumulative impact of dam construction on the Himalayan environment. Efforts to promote cooperation and data sharing among the countries have faced challenges. The management of the river is now an important topic in regional discussions and policy planning. The Chinese government presents the Yaxia project as a significant development in clean energy production, economic advancement, and engineering capability. In contrast, India and Bangladesh express concerns regarding water resource management and national sovereignty. Among local Tibetans, opinions vary. Some anticipate employment opportunities, while others are concerned about potential impacts on land use and cultural traditions. Environmental groups highlight possible seismic risks and long-term ecological effects associated with the project. The project's outcomes may influence not only the river itself, but also the broader context of regional collaboration. The Yarlung Tsangpo Megadam represents a significant development in hydroelectric infrastructure, offering potential for renewable energy generation alongside notable challenges. These include seismic considerations, environmental impacts, and effects on local communities. The project's influence is likely to extend beyond the immediate region, affecting river systems, neighboring countries, and future approaches to large-scale infrastructure.